sums very quickly. We're going to do 3 sums as fast as we can. But first, what we have done so far, we have talked about the basic identities. The basic identities are sine theta by cos theta is identical to tan theta, then sine square x plus cos square x is 1, from which we get 2 more, which we get cos square x is 1 minus sine square x, and sine square x is 1 minus cos square x. Of course, sine square is getting in terms of cos square getting in terms of sine square, so this is something very handy. But we might also want to use sine square and cos square in terms of other. There's another identity, we'll talk about that later on. The next one we talked about is the reciprocal identities. Reciprocal identities. So these are 1 by sine x is cosec x, 1 by cos x is sec x, and 1 by tan x is cot x. One thing that must be mentioned is that since tan x is sin x by cos x and 1 by tan x is cot x, so we can call the reciprocal to be cos x by sin x. And we have some additional identities. And they are tan square x plus 1 is identical to sec square x, and cot square x plus 1 is identical to cosec square x. Of course, these can be rearranged. We can say tan square x is sec square x minus 1, and cot square x is cosec square is minus 1. This can also be said. So these are the identities that we have talked about, and we have also talked about 2 things that we have proved, which is sine 2x is identical to 2 sine x cos x, which means that sine 4x can be written as 2 sine 2x cos 2x, as if double angle, half angle. If this is 4x, this is 2x. If this is sine 10x, then this would be 2 sine 5x cos 5x. Double angle, half angle, this is what it means. And we have seen cos 2x, which can be written as cos square x minus sine square x, but we use most of the time the other 2 versions, which is 1 minus 2 sine square x, and the other version is 2 cos square x minus 1. So this is what we have seen so far. Now let's do a sum. Now let's scroll down. The first thing that we can do is a very common sum. It's first, this is given, sine a plus b, the sum of angles is given, and cos a plus b, the sum of angles of cosine is also given. So this information is given. So what we have to do here is we have to find the expression for cos 2 theta in terms of cos square theta, so which we have already done. So let's start with a. So we will start with left hand side, so which is cos 2 theta means cos theta plus theta, and this is, we know the identity, it is cos minus sine. So we will write cos theta minus sine theta, and again we can write from here cos square theta. Again, this is not cos theta square, it is cos square theta minus sine square theta. Of course, we have to express this in terms of cos square theta, so we have to find an identity of sine square theta, and we had seen before the identity for sine square theta is 1 minus cos square theta. This one, sine square theta, is identical to 1 minus cos square theta, part of the basic identity. So we can write cos square theta minus, we have to group a bracket, that is very important, minus 1 minus cos square theta. So we get cos square theta minus 1, minus into minus is plus, cos square theta, so this would be 2 cos square theta minus 1. So therefore it has been expressed. So there is no left hand or right hand, so we don't have to write left hand side equal to right hand side. This is what I have to prove. Now the next one, write down an expression for sine 2 theta in terms of sine theta and cos theta. So another of those common sums, so we can write the left hand side is sine 2 theta, which is theta plus theta, and we know that sine 2 theta or theta plus theta is sine A cos B plus cos A sine B. So this is going to be sine theta cos theta plus cos theta sine theta. Of course it's the same thing, sine cos or cos sine, they're the same thing, so if we add it, it will become 2 sine theta cos theta. So this is also expressed as sine theta and cos theta. Now number C is the new one here. Number C, they have to we have to prove that cos 3 theta in terms of cos. That's what we have to do. Cos 3 theta has to be expressed in terms of cos. So let's do number 3. So here the first thing that we have to do, so let's write left hand side cos 3 theta. This 3 theta, since in the previous sum we have done cos 2 theta and sine 2 theta, so we can write cos 3 theta as theta plus 2 theta. So in that case we can write from the identity of cos A plus B, from this identity cos A plus B, cos minus sine sine. So from that identity we can write that. So let's write cos theta cos 2 theta minus sine theta sine 2 theta. So cos minus sine sine. Now notice that we cannot just multiply these two and write cos square because the angles are different, so it means they are completely different creatures. You have to consider cos theta as one entity and cos 2 theta is another entity. So the answer that we have to express, every angle is theta, so you have to break cos 2 theta into theta, and for that we have the previous sum where we have written cos 2 theta as 2 cos square theta minus 1. So let's take help of the previous sum. So cos theta would be the same, let me give a bracket here, and cos 2 theta expressed in terms of cos because the answer that we have to prove is expressed in terms of cos. So cos 2 theta is going to be 2 cos square theta minus 1. So instead of cos 2 theta I am writing 2 cos square theta minus 1. So I have expressed cos 2 theta as cos square theta. Now the next one, sine 2 theta, is going to be, we have seen 2 sine theta cos theta, so this is going to be 2 sine theta cos theta. So we have expressed both sine theta and cos 2 theta and sine 2 theta broken down as in the previous sums. So double angle half angle rule. Now if we multiply the cos theta with the cos square theta, we are going to get 2 cos theta cos square theta is cos cubed theta minus cos theta into minus 1 is going to be cos theta. So we have multiplied cos theta with 2 cos square theta and cos theta with minus 1. We get this. Cos theta into 2 sine theta cos theta is going to be 2 sine square theta cos theta. So we are going to get 2 sine square theta and cos theta. So now we get 2 cos cubed theta minus cos theta minus 2. Now we have sine square here, but we need only cos here, so we have to change the identity of sine square. So what can we do? How can we change sine square into cos square? So we need to look for an identity, and we have the basic identity here. So the basic identity that we see here is that sine square can be written as 1 minus cos square. So from the basic identity here, so if we do the sum using the basic identity, we can change it. Let me write the cos theta first, it will be more convenient. So sine square theta can be written as 1 minus cos square theta. From the basic identity I have changed the identity, so this is 2 cos cubed theta minus cos theta minus 2 cos theta into 1 is 2 cos theta, and minus 2 cos theta into minus cos theta is minus into minus is plus 2 cos cubed theta. Now the final line is 4 cos cubed theta minus 3 cos theta. Let's see whether we have 4 cos cubed theta. 2 cos cubed theta plus 2 cos cubed theta is equals to 4 cos cubed theta minus cos theta minus 2 cos theta is minus 3 cos theta. Therefore the left hand side is equal to the right hand side. We have proved this.